In this video, I'm not teaching you anything new. I'm just running through a couple more examples of graphing quadratic functions, figuring out where the vertex is, where the intercepts are, what the graph looks like, that sort of thing. So what about f of x equals negative x squared minus 8x minus 16? I see right away that is a quadratic function, so the graph is going to be a parabola. And in fact, I can see that it's the kind of parabola that opens down because of the negative in front of the x squared, right? Okay. What about the vertex? Well, I can set up my negative b over 2a. Here that would be negative 8 over 2 times negative 1, which would be positive 8 over negative 2, which would be negative 4. That gives me the x-coordinate of the vertex. The vertex is a point. It's got an x-coordinate and a y-coordinate. Now we know the x-coordinate. For the y-coordinate, we take that number and put it in for x. Evaluate this function when x is negative 4. So that's negative 4 squared minus 8 times negative 4 minus 16. Remember, this means first you take the negative 4 and square it to get 16, and then you multiply that by negative 1. You take the negative of 16. Minus 8 times minus 4 is plus 32, minus 16, and that all adds up to 0. So the vertex is the point negative 4, 0. What about the y-intercept? Negative 16, or 0, negative 16. That's the constant term on the end, that's your c, and that's what you get when you put 0 in for x. The x-intercepts would be when y, or f of x, equals 0. So for this function, if we take the whole thing and set it equal to 0, I could divide both sides of that equation by negative 1 to make it a little easier to deal with without all those negative signs. So then it's positive x squared plus 8x plus 16 equals 0. Then I can factor that. That's actually a perfect square. X plus 4 squared, or x plus 4 times another x plus 4. So for that to equal 0, x plus 4 has to equal 0, or x plus 4 has to equal 0. And that means x equals negative 4. So this is one of those where instead of getting two different solutions, we just got one solution that kind of showed up twice. So there's only one x-intercept. It happens to be the vertex. Hey, I bet I could have predicted that. When we got a vertex that was on the x-axis, and that was, well, since it opens downward, that was the highest point on the graph. That's going to be the only place it touches the x-axis. So the vertex at negative 4, 0 is also the one and only x-intercept for this parabola. And remember, we said the y-intercept was at 0, negative 16. And so there's our parabola. And what about this one? F of x equals negative x squared minus 6x plus 0. So this would be a parabola that opens down. The vertex would be, well, if we do our negative b over 2a, that would be negative 6 over 2 times negative 1. So positive 6 over negative 2 is negative 3. That's the x-coordinate. Then for the y-coordinate, f of negative 3 would be minus negative 3 squared, minus 6 times negative 3. And that's minus 9 plus 18, which is positive 9. So the vertex is at negative 3, positive 9. The y-intercept? 0. If we put 0 in for x, we get 0 for y. So that is the y-intercept. And I'll bet that's also going to be one of the x-intercepts. So what about the x-intercepts? If we take our function and set it equal to 0 and solve, we can first we can divide both sides by negative 1. Then we can factor x squared plus 6x just by pulling out the common factor of x. It factors into x times x plus 6. So either x equals 0 or x plus 6 equals 0. in which case x would equal negative 6. So there's our two solutions. That gives us our two x-intercepts, 0 and negative 6 on the x-axis. So here's the graph. It's got a vertex up at negative 3, 9. It's got a y-intercept at 0, 0, which is also one of the x-intercepts. And the other x-intercept is over at negative 6, 0. And notice that the vertex with an x-coordinate of negative 3 is halfway between where the x-intercepts are, at negative 6 and 0. If that doesn't happen, something's wrong somewhere. You probably made a mistake doing something or other.